GMAT all day.
Now let's take a look at that same VIC question that we just did, this time using the testing numbers approach, because anytime I take a practice test and I come across a VIC question, regardless of how I did it on my actual practice test when I'm reviewing, I always try and do it the other way, even if it's the less optimal way, because that might not always be the case. So even if for this question, it might seem like algebra is the better method, you might not always be able to do algebra. So the ideal situation is be able to do it both ways. And so you need to get comfortable testing numbers, you do need a little bit of practice doing it and doing it in an organized way. So let's do that here. I'll read the question one more time. A certain village's population was X 2 years before the bubonic plague. In the year before the plague hit, the village's population increased by Y%, only to decrease by 10Y% after the plague hit. Which of the following expressions represents the population of the village following the plague? So when we are testing numbers, what we are doing is we are coming up with values for X and Y, as well as 10Y. So 10Y, though we're not coming up with a value, it's going to be dependent on the value we come up with for Y. And then the right answer choice, so we have to plug those values in to our answer choices. So first we got to use those values, come up with our population following the plague, and then we got to plug our numbers we came up with into our answer choices, and the right answer choice is the one that matches the population we calculated. And so you want to choose numbers that are going to give you easy numbers to work with to make the arithmetic easier and more manageable, because that is mostly what you're doing when you're testing numbers. You're spending most of your time just doing arithmetic. And so in this case, let's say, even though we're not going to be plugging in our 10Y, we're going to need to use it to calculate our population. So let's say I want that to be 20, and therefore I want my Y to be 2. So Y is 2, 10Y is therefore 20, and X, so X is our original population, so let's say that's 100. And these seem like pretty good numbers. And so when you come up with your numbers, one thing you want to do is you want to box them off, star them, because these are the numbers you're going to have to retrieve later and plug in to your answer choices. And you don't want to have to think it all when you're going back and retrieving them. So for example, my Y here is equal to 2, right? And so that means my population increased by 2%. So even though my Y is equal to 2, 2% is 0.02. But I don't want to be plugging in 0.02 into my answer choices. I want to be plugging in 2. And so I have to remember Y is equal to 2. Even though the population increased by 2%, Y is equal to 2. So box off your values, star them, so you can easily retrieve them. So now we got to actually calculate what our village's population was. So it started with a population of 100, and that was 2 years ago. And then we had 1 year. So a year after that, it increased by 2%. So it should have gone up to 102 people. And then it decreased by 10Y, or 20%. So a 20% decrease is the same as 80% of. So our population should be 102 times 4/5, or 0.8, which is what? 408 over 5. Now, don't panic. So this doesn't really make sense, because this here is a fraction, a decimal, and in the real world, we can't have partial people, but this is just a hypothetical situation. And so the math here should still work out, and maybe it sort of does make sense. If we had a plague, some people's arms fell off, so maybe we can't have partial people. But the fact that it doesn't make a whole lot of sense shouldn't really matter in this case, because these are values we just came up with. It's not necessarily the actual numbers. And so when you choose smart numbers, yes, you want numbers that are going to give you integers ideally, but you also don't want to panic when a fraction shows up, because you don't want to go back and have to re-choose new numbers, because who knows if those numbers are going to work out. So I'm perfectly fine with this number here, and I don't even need to worry about converting it to a decimal, because all my answers are presented as fractions. And so I'm just looking for 408 over 5. As long as this fraction here is fully reduced, I should be able to come up with that without even knowing what 408 over 5 really is. And so now these I have to remember. So I want to plug in 100 for X, 2 for Y, and then I want to select the answer choice that gives me 408 over 5 as my answer. And so starting with statement 1, or I should say, not statement 1, it's not data sufficiency, answer choice A. So this X would be 100 times 1,000 minus 90 times Y, so 90 times 2, which is 180, minus Y squared, so that's minus 2 squared, so that's minus 4, all over 1,000. So notice also one thing I'm not doing is I try not to do that much arithmetic as I go because I am looking for things to cancel out, to combine. If I see that an answer choice is not going to be anywhere near 408 over 5, for example, if I see it's going to be negative, for example, then I don't need to do any arithmetic because it's obviously not going to be the right choice. And so I only do arithmetic at the end once I can fully simplify it. So for example, here, I can cancel this out. And so 100 over 1,000 is just the same as 1 over 10. So here I'm just left with 1,000 minus 180, which is what? 820 minus 4. So 820 minus 4 should be 816 over 10. And lo and behold, I can divide each of these guys by 2 and I get 408 over 5. And so I would stop here if I were testing numbers and I would say A is the answer choice. Now, it is true that one of the risks of testing numbers is you could come up with 2 answer choices that give you the same number. And in that case, you would have to come up with new numbers and retest both of those answer choices. I do not do that though, because if you were good at coming up with unique numbers, smart numbers, it should be very rare that you would get 2 answer choices that give you the same result. And so the way you do that is you want to choose different numbers with unique values. You want to stay away from choosing numbers such as 0 or 1, because even though they might make your arithmetic a lot easier, what you are doing is you are increasing the chance that 2 of your answer choices are going to give you the same result. And so I don't, once I get an answer that matches, I don't keep going to make sure none of my other answer choices don't give you that same value, but you can test them here. I can almost guarantee you none of our other answer choices will give you 408 over 5. And so once I got this, I'd be done and move on. And we got lucky here because A happened to be our answer choice. It doesn't have to be the case. In fact, on the more an actual test, I might not have started with the first answer choice. I might have started with C or D because those look like they would they involve the least arithmetic. But in this case, we got lucky, and so I'll take that. A.